So differentiation. Okay, so how we differentiate a function? Okay, so here I am differentiating a function d by dx of y. What does it mean? Okay, so here d by dx of y means we are differentiating the function y. We are differentiating the function y, differentiating y. Okay, so this dx represents, what does it mean? The dx represents with respect to x, with respect to x. Okay, we are differentiating with respect to x means we write d by dx of y. Okay, if we are differentiating x, we write x in place of y. Okay, so like that, whatever the function we are differentiating, we write in place of y here, in place of this d by dx of sine x. Okay, so we write sine x here. D by dx of log x, we write log x here. D by dx of x, we write x here. D by dx of some e to the power x, we write the e to the power x there. We d by dx of root x, we write the d by dx of root x in place of y. Okay, so we write the function whatever we are differentiating. Okay, so now for example, okay, so if we take the formula d by dx of constant c, d by dx of c, or we can also write it as d by dx of constant, any number. Okay, whatever we differentiate, okay, d by dx of constant equal to 0, and d by dx of x, if we differentiate the function x, we get 1. D by dx of x is equals to 1, and d by dx of log x, logarithm function, d by dx of log x is equal to 1 by x, and d by dx of exponential function e to the power x is equals to e to the power x only, e to the power x only, and d by dx of, okay, x to the power n, x to the power n formula, n into x to the power n minus 1, n into x to the power n minus 1 is the formula for x power n. Okay, so now d by dx of u by v. Okay, so we'll discuss the d by dx of u by v. Okay, so if we take d by dx of uv and u by v, also we'll discuss. Okay, so d by dx of u plus v, u plus v, u minus v. If you have two functions and in between the two functions, whenever we have addition or subtraction, okay, u plus v or u minus v, u plus or minus. Okay, so then we write the d by dx for the first function plus or minus, we write the d by dx for second function, we write the d by dx for second function. If we have, okay, so differentiation for u into v, u into v, the product, whenever we have the product, then u outside and d by dx of v plus v is outside and d by dx of u. Okay, one function, u outside differentiating v outside differentiating the function. Okay, so u here, and if you have, okay, so derivative of u by v, then how do we differentiate? Okay, we differentiate 1 by v square into v outside and d by dx of u minus u outside and d by dx of v. This is the formula for u by v, and okay, so once we'll also discuss the formula based on x to the power n. Okay, so here d by dx of x power n is equals to n into x power n minus 1. Based on this, we can apply other, okay, so derived formula. Okay, so d by dx of 1 by x. 1 by x is minus 1 by x square. Minus 1 by x square. So this okay, d by dx of 1 by x. How do we write the d by dx of x to the power minus 1? Okay, we write the d by dx of 1 by x as x to the power minus 1. After that x to the power minus 1, we apply this formula. Minus 1 into x to the power minus 1 means minus 1 by, okay, x square we get. Minus 1 by x square. So it is a derived formula from x power n. Minus 1 by x square. So like that we can also write the formula d by dx of root x. D by dx of root x formula is 1 divided by 2 root x is the formula for d by dx of root x. Okay, so this is also frequently we use. This is also derived formula only. D by dx of root x, we can write it as d by dx of x to the power 1 by 2. X to the power 1 by 2, power 1 by 2, in place of n we have 1 by 2. So we write it as 1 by 2 into x to the power 1 by 2 minus 1, and we'll simplify. By simplifying, we get 1 by 2 root x. Okay, so this is also derived formula only. This is also derived formula. So these are the formula we are going to use in the next exercise. Okay. So exercise 19b. Exercise 19b. Differentiate the following functions. Differentiate the following functions. The first question is ax whole power m plus b to the power m. Okay. So now I am differentiating the function here. So given function is ax whole power m plus b power n. I am differentiating with respect to x now. Okay. So differentiating with respect to x. Then what we get d by dx? We have to write the d by dx for both the terms. Okay. So d by dx of ax whole power m plus b power m. Okay. Either you can write the d by dx separately, or take one more step, writing d by dx now. Okay, for complete term, this is equal. Now write separately. D by dx of ax whole to the power m plus d by dx of b to the power m. Okay, written d by dx for first term and the second term according to the normal. Okay, so exponents. Okay, formula. This power is applicable for both. Okay, so that means we can write this as a to the power m and x to the power m. Normal formula it is. D by dx of b power m. B power m. This is a constant. This is a constant. D by dx of b power m is a constant. So I am writing 0 here. I am writing 0 here. Okay. So that is nothing but d by dx of constant. D by dx of constant is equal to 0. Okay. So now I am writing this power coefficient. Okay, a to the power m coefficient I am writing outside. Okay, so a to the power m outside, and d by dx of x to the power m. X to the power m. Okay, this a power m is as it is, and x power m we have the formula. Okay, d by dx of x power n formula. What is d by dx of x power n formula? Okay, that is n into x to the power n minus 1 is the formula. So we have to apply this formula now. Okay, if we apply the formula, d by dx of x power m is there. M into x to the power m minus 1. M into x power m minus 1. Okay, so what formula we used here? Here we used the formula d by dx of x to the power n is equals to, okay, n into x to the power n minus 1. Okay, so repeat once the formula. D by dx of x power n is equals to n into
d by dx of x power n is equals to n into x power n minus 1.
Very good. Okay, so once again, d by dx of x to the power
d by dx of x power n is equals to n into x to the power of n minus 1.
Yes, this is most important formula. Repeatedly we use this formula. Okay, so the final answer for this is, okay, m is a coefficient, and okay, writing as it is, and a to the power m also coefficient only, and x to the power m minus 1. Okay, this is only the final answer. This is only the final answer. Okay, here what formula we use? We use the d by dx of constant equal to 0, and one more formula is d by dx of, okay, d by dx of x to the power n. D by dx of x to the power n is equals to n into x power n minus 1 is the another formula we use here. This is the final answer. Okay, so now if we go to the next question here, okay, so differentiate the following. Okay, so this is the function here. We are going to differentiate this function. Okay, now I am differentiating with respect to x on both sides. Okay, differentiating with respect to x on both the sides. Okay, if we differentiate with respect to x on both sides, d by dx of 7x power 6 plus d by dx of 8x power 5 minus d by dx of 3 into x power 4 plus d by dx of 11x square plus d by dx of 6x plus d by dx of 7. Okay, so now this is the first step here. Okay, what I did, I written the d by dx for each and every term. When we have addition or subtraction, we write the d by dx for each and every term. The next step is we have to write the coefficients outside. Okay, 7 is a coefficient, 8 is a coefficient, 3 is a coefficient here. Okay, 11x square coefficient, writing all these coefficients outside. Here there is no variable, so that's why this is a constant. It is a number. Okay, we write 0 for that. Okay, now writing 7 outside, and d by dx of x to the power 6 plus 8 is outside, and d by dx of x to the power 5 minus 3 is outside, and d by dx of x to the power 4 plus 11 is outside, d by dx of x square. Okay, plus 6 is outside, and d by dx of x plus d by dx of 7. Constant derivative is 0. Constant derivative is 0. Okay, so here the formula we use, the d by dx of constant, d by dx of constant is equal to 0. Now here 7 is a coefficient, writing outside x to the power 6. X to the power 6 means 6 into x to the power 6 minus 1. Okay, plus 8 outside. Okay, x to the power 5 into x to the power 5 minus 1. Okay, minus 3 is a coefficient written outside, and x power n formula. Okay, so n into 4 into x to the power n minus 1, 4 minus 1 plus 11 outside, x power 2 into x power 2 minus 1 or 2x. Okay, plus 6 as it is, d by dx of x is equal to 1. Okay, so here what formula we used here, d by dx of x to the power n, d by dx of x power n is equal to n into x to the power n minus 1 is the formula. Okay, so now after this, okay, so what is the next step here? 7 6 42. Okay, 42 x to the power 5 plus 8 5 is 40, x to the power 4 minus 3 4 is 12 x cube plus 11 2 is 22 x and 6 1 is 6. Okay, this is the required solution. Okay, here what formula we used in this okay, so problem solution, d by dx of constant equal to 0, and d by dx of x to the power n is equal to n into x power n minus 1. Okay, so we used these two formula in this solution. Okay, so now next question, d by here 3 divided by x to the power 5. 3 divided by x to the power 5. So now I am differentiating with respect to x on both sides, on both the sides. Okay, if we differentiate with respect to x on both sides, then what we get? Okay, so d by dx of 3 divided by x to the power 5, 3 divided by x to the power 5. Okay, I am writing this as okay, first step I am writing the coefficient outside. Here the 3 is a coefficient. I am writing the 3 outside. Okay, so if you write the coefficient 3 outside, then okay, 3 is out and d by dx of 1 divided by x to the power 5. Okay, so 3 is outside as it is, and d by dx of 1 by x power 5, we can write it as x to the power minus 5. If we take it to numerator, we get negative sign. So what is the formula here? Normal formula. So a to the power minus m or a to the power minus n is equal to 1 divided by a to the power plus n. Whenever we change the power from numerator to denominator or denominator to numerator, we have to change the sign, negative to positive, positive to negative, like that. Okay, so now here 3 into x to the power minus 5, x power n formula we have to apply. N into minus 5 into x to the power minus 5 minus 1. N into x to the power n minus 1 is the formula here. Okay, so what formula we used here? D by dx of x to the power n is equals to n into x to the power n minus 1. Why I am writing again and again the formula? Make it a habit of writing the formula. So without by hearting the formula, easily you will get. Whenever you refer the notes also, it is very easy for you. Okay, so this is equal to 3 5s of 15 minus 15 into x to the power minus 5 minus 1 is minus 6. Okay, so if you take this again, if I am applying a to the power minus n formula again, so take it to denominator, so we get positive. So minus 15 into 1 divided by x power plus 6 now. Okay, the final answer is minus 15 divided by x to the power 6. Okay, this is the final answer. Okay, so what formula we used here? Here we used general formula, that is a power minus n is equal to 1 by a power plus n, and d by dx of x to the power n is equals to n into x power n minus 1. Okay, that's it. This is the required solution. Okay, so next, if we go to the next question, 7 divided by okay, x to the power 2 by 3. This is also almost similar to the previous problem. Okay, differentiating with respect to x. Okay, so now we have to write the d by dx of 7 divided by x to the power 2 by 3. X to the power 2 by 3. Okay, in this here the coefficient 7 is a coefficient for x to the power 1 by x to the power 2 by 3. That's why I am writing this outside. Okay, so 7 I am writing outside, and d by dx of 1 divided by x to the power 2 by 3. If we take out the 7, 1 divided by. Okay, so here again I am applying the same formula. Okay, so then if we take it to numerator, x to the power minus 2 by 3, we get it minus 2 by 3. Okay, so what is the formula here we used? Okay, a to the power minus n is equal to 1 by a to the power plus n, or 1 by a to the power plus n means if, okay, a to the power minus n. Okay, so